Hello, everyone. Good evening to all, and hopefully we can get started. Or I hope a few more people might join shortly. So again, this is going to be our final session for this particular, series. Right? We had a series of 5 sessions. Actually, this one got a little spilled over to another session today. A couple of problems, of course. So essentially. That's what we're going to be discussing today. Yeah. And what else? So there are a couple of problems, not major, I would say. I think we looked at a lot of interesting problems last few sessions, right? Especially on, let's say, recursion, backtracking, and dynamic programming, right? Memoization, right? So very interesting set of problems. Hopefully you'll try to uncover more problems in those lines and then try to solve, and that should help you as you move forward, right? Okay. So can we get started, or you expect some more people to join in? Do you want to reach out to your cohorts, people, and in case if they're joining, we can wait a couple more minutes and then get started, right? Okay, so should we get started, or do we want to wait for some more time? Let me know. It's all up to you guys. All right. Okay, super. Let's get started then. We don't have a lot of problems to deal with today, so it's just a couple of problems that we would be looking at, right? And so let me bring up my screen here. Before that, I would like to share my screen. That way you'll be able to see what I'm sharing, right? Okay. Are you able to see my screen right now? Okay, great. So there we go. Let me bring my PDF also, just to essentially show what we're trying to solve here. Okay, super. So first one would be the common books problem, right? I think we'll look at this. So we have a library where multiple books are arranged in different racks. Consider a rack where there are multiple layers in which books are placed. Every book has a unique ID. There are some books which are common in the layers. So essentially, your task is to find those common books. So what they're saying is, let me go back to the whiteboard, okay, and then continue. Okay, someone came to 10K, right? I bet. All right. Let me go back to the slide. Size these a little bit. Okay, super. And so essentially, we have a library where there is a rack, and it's possible, and each book has an ID, right, as they have mentioned here. And it's possible that certain books, they could be duplicates and they could be present in all the racks, is what they're saying. Each rack has a layer, has multiple layers, right? And each layer could have um, duplicate copies of the same book, right? That's what they're saying. And so essentially we need to find those common books across the layers and then output those books, is what they're saying, right? So for example, let's assume that let's take this example here, right? So we have and this essentially the input here is in the form of an array, 2D array, right? So the first row would have the first layer. So here it is 16, 13, 19, right? And 12, 16, and 19, 13, 16, and 19. Okay? So what do we have to do here? We have to find the common elements across the layers, right? Across all the rows, that is. So right now, if you look at it visually, right? So we have 13, 16, 13, and 19 in the first row. And if I look here, there is 116 here in the second row, and 116 here in the third row, right? So that qualifies to be part of our output. So what's going to be our output? So output would be a collection, right? And I say collection, it's a generic word that I'm using. It could be, again, a list, or it could be an array, or anything of those kinds, right? A linked list, anything, right? It's going to be it's a linear data structure, right? So we can say, because 16 is in the first row, 16 is in the second row as well, 16 is the third row, it qualifies to be in the output, right? Okay. And what else can we do here? So if you look further, if you look at 13, 13 is in the first row, right? However, 13 is not there in the second row, right? And so it doesn't qualify to be in the output, the final output, right? And what about 19? So 19 is going to be in the first row, right? Which is here, second row and third row. So obviously that qualifies to be in the output, right? Okay. All right. Give me a moment here. Give me a moment here. I just need to take care of something. Yeah. All right. Sorry, folks. Yeah, we just got started. All right, sorry folks, sorry for the interruption. I hope you're all back. I'm back at least. And so let's go back to the problem domain. Yeah, you can hear me all right? You're able to hear me all right? Network problem? Are you okay? Are you doing okay right now? How is it right now? Oh, you still have a network problem? Now it's okay. Let me know. I can switch to another network, which is my which is a different network in case the problems persist. Okay. All right. Super. Okay. Let's go back to the problem domain. So we were saying that we are given an array, and we are supposed to, not an array, it's a representation of a certain problem domain, and we are representing it as an array, right? So essentially we have 16, 13, and 19 as our book IDs. These are nothing but book IDs, right? And we have to check if all the IDs, certain IDs occur in each of the rows, right? Which are essentially the layers of a rack. And if that is the case, then we actually output them here in the form of a list or as a form of an array, right? Okay. So how would you go about doing this, right? I mean, if let's say I were to look at it, right? How if it were to be a brute force, how would we do that? Any thoughts? So essentially, one way would be to check if look at each of the numbers and check if it occurred in all the rows, right? So that would be a kind of a very very unelegant solution, right? So essentially, take one item, right, and then look at each of the rows and then check if that happens to be in the in each of the rows, right? What other one was other one, right? I mean, you can actually essentially put them in some form of an object or a map, right? So let's say this is set 1 for, let's say, row 1. This is set 2 for row 2, set 3 for row 3, right? So we can check if so we could form these things and then look at all the elements, right? If it occurred in all the sets, then we are good to go. I think that's one way that we can do. So essentially, this would be a order of let's say this was a m by n matrix, right? So which means it would be we would be going through the entire array, right? And that would be a, so let's say this was the m by n, let's say n elements in this one, right? So we would be going through the entire list of elements. So that would be an ON solution, right? That would be an ON solution. And also you would have you'd have sets here, right? That would be again, or that would be, this is again time complexity, of course. And you would have also have a space complexity to accommodate these sets, right? And this would be order of, let's say, number of columns, right? So essentially order of m, right? This is m by n, by the way, right? So that's how you would do it. I mean, worst, I mean, a brute force method. Again, another solution is on the same lines. So what you would do is you would essentially store only the first row in the set, right? And we go ahead and scan through the next set of rows and check for each of the elements, right? If it is part of the, if it actually occurs in the set, right? And that is another method that you can do as well. So again, both of them would be an order of n solution, but just that with a limited, but in this case, you would not be storing all the all the elements in the set. It will be just the first row in the set, right? So that's another approach that you can do. Any other approach that you can think of? Any other approach that you can think of? That could be more, could be anything, right? It could be a brute force method, or it could be a more optimal method, right? So let's actually go ahead and look at the implementation here, right? So I'm going to go back to my IDE, right? Okay. So let's go to the IDE here. I'm going to go back to the IDE and start coding this one out. Okay. It's right here. Okay. So here I'm going to have another function here. I'm going to call that and common underscore JS. I'm sorry, common underscore books JS. All right. Super. So what would be the function name here? I would just say find common books, right? That would be the function name. The matrix. It's going to get a matrix, of course, which is going to be our input. All right. So first thing you want to do is find out the bounds of our matrix. So let's get the rows const m is equal to matrix dot length, right? Okay. And how would we get the rows? All right. I think there is a mistake here. Okay. Similarly, const n is equal to matrix 0 dot length, right? That's going to be our column length, number of columns, that is, right? Okay. So what do we want to do here? We want to maintain, so essentially, we take the first row. Let's assume that we have something like this. Let me get some input. That way, we'll be able to associate or relate to that with an example. So let's say this is our input, right? And so this would be the input. And essentially what we do is we actually take the first row of the input and store them in some object, right? So I'm going to call that common books, right? So I'm going to say const common books is equal to, this is going to be an empty object. All right. So what I'm going to do here, I'm going to go ahead and look through the first array, let's say I'm going to go through the first row and look at and then store them in the common books, right? So for that, I'm going to open a for loop and say for let I is equal to 0, right? And I'm going to run this only for the first row, and I'm going to run it. Yeah, give me a moment here, okay? Apologies, everyone. I had an interruption, unfortunately, so had to go, and hopefully there'll be no more interruptions. We are good to go here. Okay. All right. Let me go back and share my screen one more time. Okay. So, okay. Was there any question? Okay. Actually, I had unmuted myself, right? Because I had an interruption. So that's why there was a silence for some time. But I'm back right now. Can you hear me all right? Okay. Super. That's great to know. Let's get started. Okay. Hopefully, there's going to be no more further interruptions after this. I promise. Okay. So let's say, so essentially what I'm doing here is I'm going to go through this entire row, right? And for each of the columns, I'm going to store them in the common books object, right? So I'm going to say let I is equal to 0, I less than n, of course, because we want to loop through the first row, right? And go over all the columns, right? I less than n, I plus plus. Okay. All right. So what I'm going to do, I'm going to get the first book in the first row, right? So I'm going to say const, going to be const book is equal to, what is it going to be? How can I get it? I'm going to say matrix at 0, which is going to be 0th row, right? And the ith column, right? Which is going to be the variable right now, right? So I'm going to essentially get this element, and this element, right? And I'm going to say, I'm just going to go ahead and add it to the book, right? And say if, remember, because this is going to be a book, this is going to be an object. Obviously, there won't be a scope for any let's say duplicates, right? However, we'll still go ahead and then check for a duplicate, right? So I'm going to say if the current element, right, if it is not present in the common books, I'm going to go ahead and add it, right? So I'm going to say if not common books of book, right, is not present, what would I do? I'm going to just say add it to the current, right? So I'm going to say common books, book, and set it to 1, meaning I have one instance of that in the current row, right? Okay. And in case there are duplicates, you will end up having only one, right? If you recall, right now 16 and 19, 19 actually repeats in the first row, right? So eventually the common books will have something like this. It will end up having something like this. So 16, 1, and 19, 1. Right? That's what you would have. All right. So that's what this particular first loop is going to do, right? Okay. So now that we have the first row inside of the common books object, what we can do is we'll go through the rest of the rows, right? Which is going to be starting from row 1 and row 2, right? And then check if any of those items happen to be in the common books, right? Okay. So let's go ahead and do that. I'm going to open another for loop here in order to do that. So I'm going to say for let, and this time I'm going to start I at 1. Okay, I'm going to say let I is equal to 1. Okay, and I is less than m, right? M is the number of rows. I want to go through each of the rows here. Okay, all right, and I plus plus. Okay. So essentially, this has to be a for loop, right? So I'm going to go over the it'll be a nested for loop to be precise. So I'm going to say for let j is equal to 0, right? And this is going to go over all the columns for that particular row, right? So I'm going to say j less than n. And j plus plus. All right. So I'm going to get the current element from this first row. I'm going to say const current is equal to matrix at I j, right? Okay. So what do? I want to check if this current element is part of the common books, right? Okay. So how do I do that? I'm going to say if common books current, I can either do this way, or I could also say do it with a negation, but I will do it slightly differently this time around. So if it is not equal to undefined, right? All right. And common books current okay, this is going to be important. So I'm going to say common and actually this need not be needed, but I'll still put this check in. Common books current is equal to I. Okay. So when you say I, which means it was already present here. However, remember that if we are putting this only if this, because this check is there, right? This check need not be there, right? So I'm just checking if common books current is equal to I. I'm going to essentially, I think this is needed. Okay. So I'll allow me to complete this, and then I'll come back and then explain this. Okay. Or so I'm going to say current. So what it is trying to do here is that when you're in the second row, right, it expects you to have the common books value to be 1, right? So for example, let me go back to the drawing board here. So let's say we had, so let's say we have processed 16 and 13 and 19, right? So we are checking if 12 is, so our set initially is going to be something like this, right? Or for that matter, the map is going to be something like this. So 16 would be 1, 13 would be 1, and 19 would be 1. Right? So this would be our representation of the object after processing the first row, right? So when we come to the second row, we check if 12 is already present, right? So how do we do that? Let's go back to this code here again. So we're saying, if you look at this right now, let me shrink this further. Okay. So we're saying we are checking if the second row, right, which is going to be starting from the second row by indicated by I is equal to 1, right? We're checking if the current row, which is current element, current book, which is 12, is currently there or not. Currently, it is not undefined, right? Right? So if it is not undefined, only then we're going to essentially come into this block. So 12 is not here, right? We don't even want to process that in that case, right? So that is what it does. However, remember, let's say we move to this particular element here. And then subsequently, we actually process 16 and 19, right? So remember, 13 was already there, right? So at this, after processing this, what would be our value? This was the value initially at I is equal to 0. After processing second row, it would be how much? 16 would be, can you tell me? 16 would be 2, right? 13 would be 2, right? And 19 would be 2. Are you with me? Are you with me? Actually, 13 would not be 2, right? 13 would be 1. 13 would be 1, right? Because we are not adding any 13 in the second row, right? Okay. So, so essentially, this is the first state. This would be this first state. This would be the second state after processing the second row, right? So essentially, what happens is that we are adding 13 here. We added 13 in the first row. However, we didn't add 13 in the second row, right? We only added 16 and 19. So essentially, 16, the count of 16 becomes 2. Count of 19 becomes 2 as well, right? Okay. So here comes the interesting part. So let's say we come to 13 here, right? And this is going to be at I value of 2, right? Okay. What is going to be the value of I here, which is going to be the row? It's going to be the row of 2, correct? So when we go to 13, here is what we say. Is it there in the current? Is it there in the common books? Yes, it is. However, what is the count of that? Is the count equal to 2? If it is not equal to 2, we don't even want to add that, right? And how do we say 2? We say if it is equal to I, right? When it comes here, right, only if the previous count is 2, then we want to add this 13. Okay? That is the significance of the second condition. The common books current is equal to I. Making sense, right? Yeah? You with me? Hello? Okay. That's okay. No problem. So I'm going to say, let me Okay, so essentially, you understood this part, right? The first block for where we actually capture the first row in the set or the object. That part is clear, right? That part is clear. Hope so. Okay. So after doing the first row, we go to the second row, which is going to be this one. So we check and we process each of the elements, right? So we check second condition as in this condition, this condition. Okay. Okay. What is the doubt that you have, or you don't understand it? You have a specific doubt, or you I value. Okay. I is nothing but your row, right? That's the row value. So when you process each of the rows, you want to check whether the value present in the common books current is equal to I, right? Because we start in the, let's say at 0 index, right? I will be 1, right? Because it was already processed here. So we check if I is equal to 1 here, right? Making sense? Okay, super. All right. So essentially, that's what happens. And so right now, we process the second row. After processing the second row, what happens? We get 16 as 2, 13 as 1, and 19 as 2. And let's say we process the third row. We check for 13. 13 is there. However, the second condition doesn't satisfy, right? Because I, at this point in time, is this third row. And the count of 13 in our common books is just 1, right? So we don't essentially go ahead and do another addition to that, right? We don't increment that here, right? However, when you process 16, we know that I is equal to 2, right? And it has already been processed in the previous 2 rows. So we go ahead and add it, increment the count here, right? Similarly, 19 as well, right? Okay. Is that did that actually clarify your doubts, or do we still have any doubts here? Are we good here? Can I give a thumbs up? Okay, super. So essentially, we process all of them, right? And then we put them in the common books, right? And after processing everything, this is what we get. So in the third iteration, right, which is going to be state 3, these are not sets, by the way. This is, I should probably make them I. Let me, okay, I lost my, where's the eraser? I think I lost it. Lost the eraser. Okay, this is going to be iteration 1. Maybe I'll just strike it and then say this is going to be iteration 1. This is going to be iteration 2. And this is going to be iteration 3. Don't confuse it with this I, okay? Don't confuse it with this I. Okay, this is for iteration. Maybe I should just make it IT in order not to confuse you, right? This is going to be IT1, IT2, and this is going to be IT3. Okay, so when you process IT3, what happens? We have 13, because 13 occurs only once right now. We don't go ahead and increment that. We have 16. 16 already is at 2, so we go ahead and then say 16 to 3, right? And we have 19, which is already at 2. We process and go ahead and then increment 19 and then put it at 3. Okay, and of course, 13 will continue to be in this particular object array. I mean, object, the map object, right? So we have processed all the elements of the array, and now what do we do? What do we do after this? We have to go through the object and then find out again, there is another step that I missed out here, right? After adding this, we also want to check if I is equal to the number of rows, right? So I was thinking we could do it in the second step. We could have done it by going through, iterating through the common books, but we will get it done here itself. So I'm going to say if I is equal to the length of the row, right? So that's going to be m minus 1, right? Is equal to m minus 1, which means we are processing the last row, right? Okay. In that case, what do? We're going to push this to our result. So I'm going to say result dot. We have a result object. It's going to be a okay. Let's actually have a result here. So I'm going to say const result would be a list of all our common books, right? So it's just going to be an array. Okay. So result dot push, and this is going to be equal to current. Okay. Okay. So do you get it? Did you understand this part, by the way? Did you understand this part? So we're just checking if the row that we're processing here is the last row. If that is the last row, we are pretty sure that this is part of the result, right? That's why we're saying push the result to push the current book ID to the result array. Right? That's what we're saying here. Okay. All right. So finally, we'll go ahead and then return the result here, right? Where is our? Let me. So this is the for loop, right? At the end of it, we'll go ahead and return the result. Okay. Okay. All right. There we go. So are we good to go? Can we go ahead and run this program now? Do you have any doubts? Let's say let input. I think we already have the input here at the very top. Let's go ahead and copy this. Okay, so I'm going to say console.log. Okay, it's going to be find common books, and this is going to be the input. Okay, looking good. So let's go ahead and then execute this one. All right, so the node already in part 5, so common books.js. Let's see. We got only 16. That's strange. We should have gotten 19 as well. This is interesting. Okay, some debugging for us to do here. Okay, I think we gave a incorrect input, I think, right? So 19, remember, can you see something interesting here? Even though 19 occurs in 3 places, it doesn't necessarily make that as part of the output, right? Can you see that? So this is actually the correct output, right? If you look at it, 16 appears in the first row, second row, and third row, and nothing else, right? So 16 is the correct answer, right? However, instead of, let's say, I give 19 here, if I'd given 19 here, or maybe here, that would have given us a 19 also as part of the result. Yeah, there we go. Okay. All right. So let's see what is the time complexity here, right? So I think we talked about time complexity, right? We go through each of the elements. So that's going to be order of m by n, surely, right? And there is also the space complexity of order of n, right? So here, time complexity is going to be order of m star n, right? And space complexity will be order of n. All right. Super. So any questions, any thoughts, any comments? Any thoughts, any comments? All right. So we have another problem after this. So essentially, that's going to be the last problem for this series. And it will be essentially closing after this, right? So can we go ahead and start it? Or you want to take a quick dinner break or something like that? Let me know. It'll be another 30 minutes. We should be able to finish in 30 to 40 minutes, I'm thinking. In case that's going to come in the way of your dinner, I can go ahead and then we can take a quick dinner break and then come back, if that's what you want. Early break? Okay. All right. So what time you want to come back? No, I'm saying in case the next problem is going to take another 30 to 40 minutes, right? I'm thinking. So in case you want to take a early dinner, you can do so now. Then we'll come back and discuss that problem because that has two solutions, right? And I want to go over both the solutions, and that way, right? You won't feel like you are tired or feeling hungry or something like that. 9:15, you want to come back? Okay, all right. Is everybody okay with the 9:15 timeline? Is everyone okay with the 9:15 timeline? That'll be early. Okay, it's 8:52 now. So what time you want to come back? You want to hang on for another 30, 40 minutes? Or you want to look at the first solution and then take a break and then come back and look at the next solution? Okay, all right, no problem. That also works for me, if that's how. Okay, all right. So let's continue then, and then we can take a break at 9:15, as Nilanjan said. We'll take a break at 9:15. Okay, makes sense. All right. So let's go to the next problem set here, and the next problem is actually at the top, because we've been looking at the problems in a specific order, not necessarily in serial order, right? So essentially, So consider an exam hall where students are sitting in chairs. Each chair is assigned a roll number, which is a unique number, and students should sit on their assigned roll number. We need to arrange the chairs on the basis of increasing roll numbers. The task is to find the roll number of a student who should be seated on the middle chair. Okay, so they're saying it is going to be an m by n array, so which means it is going to be an odd number, right? It need not be an even number, right? And also every row is sorted, right? Every given row is sorted. That's going to be one of the key things that they are mentioning here. And let's look at the input. It says 11, 13, and 15, 12, 16, and 19, and 13, 16, and 19. Interestingly, I think this is actually a typo in my opinion, because if these are unique numbers, they have to be unique numbers, right? These are all roll numbers. I don't think it can really be a duplicate here. So maybe the problem statement here is probably doesn't reflect the input here. At least the context doesn't. But anyway, we'll take that. Okay, so what is the approach here? So if you observe the problem, we need to find the median of the given matrix, right? So a median is the middle number of sorted arrays. Okay, so it is already given that m by n is odd, right? And we can use this to find the required output. We'll use the boundary search here to find the middle number efficiently. A number will be median if there are m by n, m multiplied by n, which is essentially half the number of total numbers, less than it, right? So let's actually take an example and then essentially work through this. Yeah. Okay, I'm going to go back to the whiteboard here. Okay, there we go. Okay, so here we have this particular, excuse me. So we have this particular input array, right? This is going to be a two-dimensional matrix, right? So it's going to be 11, 13, 15, 12, 16, and 19. 13, 16, and 19. Okay, all right. So if we were to actually put this in a single dimensional matrix, right, how would it look like? So essentially, let's say this is a single dimensional matrix, all the numbers, of course. So that would be like 12, 11, 12, 13, right? Another 13, 15, 16, 16, 19, and 19. All right. Okay. So if we look at the numbers right now, all of these are in sorted. These are in sorted order, right? Essentially, right? This is all sorted. This is a sorted matrix, right? So what is the number of elements here? Right now, number is equal to 9, which is going to be odd, right? So how do we find a median? A median is something that you can find only from a sorted list, right? Then the ordering has to be in a sorted fashion. Only then you can find a median, right? That's going to be the key aspect of the median, right? And in that list, you could have duplicates. So for example, 13 occurs twice here, 16 occurs twice, right? 19 also occurs twice. So that's not a problem, right? So the only criteria here is that the median would be the middle element, right? So essentially middle element as in the numbers to its left should be the same and the numbers to its right should be the same. Okay, and that can happen only when n is odd, right? So No, start plus last by 2 is not a median. That's a mid, right? But that would be the position of the median is what you're saying. Okay. All right, makes sense. So essentially, we have, but it could also be something like, the number of elements divided by 2, right? So are you saying start index or the index at the start index? Okay, so essentially this is 0 and this is 8, and 0 plus 8 by 2 is going to be 4. So essentially even this one, right? N is 9 divided by 2. And if you look at the integral division, we're not taking the fractions here, and that would be 4, right? Okay, so the number at index 4 is the median in our case, right? So right now this is at 0, 1, 2, 3, 4, 5, 6, 7, and 8, right? So right now we're saying this is going to be our median, right? So 15 is going to be our median, because if you look to its right, there are 4 elements, right? And if you look at the left, there are 4 elements, right? So 15 is bang in the center, right? So essentially, because this is also an odd numbered array, it is easier. In case it was a, let's say, even numbered array, right? You would take, let's say, anything that was coming after 15, you would actually take a average of those two, right? That's what they do generally. But in this case, we are guaranteed that this is going to be an even, this is not going to be an even matrix or even numbered matrix. It's going to be an odd numbered matrix, right? So essentially what we're saying here is 15 is going to be our median, right? That's going to be the middle number. Yeah. So with that out of the place, how can we actually go ahead and solve this problem, right? That's the next question. So obviously there is a brute force way, and there is also the more elegant way, which is, uses a performant way to actually solve this problem, right? So what could be the brute force way here? So we could essentially have a array, which is going to be a single dimensional array, right? And then we will essentially add all these elements, go through each of the elements and add to those elements, right? Add to that array, right? So essentially it's going to be a single dimensional array, and then we'll go through each of these, scan through these rows and the columns, and then add them one by one, just like we did it here, right? So again, when we do that, it will not be sorted, remember, right? Even though the rows are sorted, when we add them in a row by row fashion, the resulting array will still be unsorted, or will be partially sorted, right? So we need to go ahead and then sort that particular resulting array, right? So we could do something like a quick sort, which is going to be in place sorting. So, and that will result in this kind of a output, right? Okay. All right. So, and then after this, obviously, it's going to be straightforward. We just take the, as you mentioned, the start and end divided by 2, and calculate, essentially extract the element at this index, which is going to be 15, right? So what's going to be the complexity here right now? So the complexity here, obviously, is going to be m by n, because we're going to scan through the entire array, plus the sorting part, right, which is going to be n log n, right? Assuming there are n elements. So this is going to be n log n or m by n log n, right? Or is it m by n? I'm saying, n, because I'm considering this as, this is going to be, it's going to be m by n for sure, right? And when you sort the array, it's going to be m, n, and log mn, right? Because ultimately mn, it represents the overall set of numbers, right? So this is going to be your, because this is going to be a, because we're representing this function in the form of a two-dimensional array, mn eventually becomes something like this, n log n, where n is a total number of elements, and here also it's going to be n, right? So essentially, the overall complexity is going to be n log n if we ignore the n here, right? Is it making sense? Does that make sense, folks? Any thoughts, any ideas, or any questions, clarifications? Or anything is fine. Okay. All right. So let's go ahead and then implement this part, right? I'm going to go back to the IDE one more time. So, and then open another file here. I'm just going to go ahead and close this. So I'm going to call that find median or middle point. Either one is fine. .js. Okay. All right. So in here, what I do, I'm just going to say define a new function. I'm going to call that const find underscore median. This is going to get us an input matrix, right? So I'm going to call it matrix. Okay. All right. So I'm going to essentially, what I'm going to do is I'm going to convert this two-dimensional matrix into a single-dimensional matrix to begin with, right? So I'm going to say const input will be equal to a single-dimensional matrix, right? Okay. And I'm going to go over the entire, scan through the entire matrix, right? So I'm going to say for let I is equal to 0, I less than matrix dot length, right? That's for the rows, and I'll have a corresponding inner loop. I'm going to call that like j is equal to 0, matrix I dot length, choose this, and j plus plus. Okay. So I'm going to say const current matrix at I and j, right? Nothing fancy here. And I'm going to push them to the input array, which is going to be my single dimensional array, right? Okay. All right. So right now we have the single dimensional array, right? And I'm going to go ahead and sort this one, right? So how do I do that? I'm going to say input dot sort. This is going to be an in-place sort, right? And I'm going to give it a function, a comma b and a minus b, right? So this is going to be in which order, ascending or descending? Ascending, that's correct. Okay, so let's actually calculate the input length here, right? So I'm going to say const input underscore length is equal to input dot length, all right? And I'm going to go ahead and calculate the midpoint. So I'm going to say const. Again, there are multiple ways of doing this. So I'm doing it a certain way. It doesn't mean it is the only thing and the right thing, right? So I'm going to use the math.floor function and make sure I do the integral division, right? So this is going to be input length by 2. And finally, what do we do? Say return input at midpoint. All right. Okay. this is all that there is to it. This is for the first solution that we are discussing, right? So very straightforward and nothing fancy here, right? The brute force, that you would essentially design. Yeah, it is. It is simple. Yeah. Yeah, I guess, compared to some of the other problems that you have seen before, I guess, in session, let's say 4 probably had more complexity problems, I think, session 3 and 4, right? Relatively, on relative scale, that is, right? Okay. So this is going to be this. So let's actually give it a, let's actually give it a spin, right? So I'm going to say const matrix. Going to be a 2-dimensional array. So I'm going to say 11, 13, 15. Okay. And 12. This is going to be 12, 16, and 19. Okay. And similarly, it's going to be 13, 16, and 19. Right? It's the same input that was given to us in the exercise. Yeah. Okay. All right. So let's go ahead and then console log the output by calling the function. I'm going to say find median. That's how I named it. Yeah. Find median, and this is going to be the matrix. Okay. All right. So I'm going to go back here, enlarge this a bit. I just want to keep it 50-50. So in case there is some error, that I can always go back to the code base, right? Okay. So I'm going to say node. I didn't save this. Okay. Node find underscore median .js. Okay, 15 is the right answer, right? So let's say we had another input here. So let's assume this was, would that be any different? Let's say this was 617, right? Would that still be the median if this was 17? So we need 4 numbers which are less than this, right, on this side. So it would be 11, 12, 13. So that wouldn't be that, right? What would be the median here now? Any guesses? Okay, that's a good guess. Hopefully that is the answer. Yeah, it is 16. Okay. All right. Super. So that is the first way of finding the solution to this one. Yeah. And we'll look at the next one. And let me know if you want to take a break right now. Would you prefer to have a break right now? Or you want to continue? You want to have, no, the thing is, the discussion is going to go for like, say, 20, 30 minutes, right? So so the question here is that you want, you can have the break only after 25 to 30 minutes. If we miss the break now, that's why I'm asking. Okay. You want to go for a break right now? Okay, all right. Right, so we'll be back by 9:33. 9:33? Okay, super. Let's come back at 9:33 then, yeah? Okay, talk to you soon. Hello, everyone. Everyone is back. Can we get started? Let me know in the chat window if we can get started. Okay, great. So I'm going to go back to the drawing board here one more time. Okay, so I'm going to go ahead and move this a little bit. Okay, there we go. It is 11, 13, 15. Okay, let's actually check it. Okay, so I'm going to take another example here, and we'll look at how we can solve that problem, right? So let's assume our input is something like this. All right. So I'm going to say 1, 3, 5, 5, 6, 9, 3, 6, and 9, right? So what would be the what would be the median here? Any guesses? Any guesses? Okay, so let's check that actually. So we have 9 numbers here. So if we arrange them in increasing order, 1 and 3, 3, and we have 2 5s, right? 5 and 5, and 2 6s, right? 6, 6, and 9 and 9, right? This is correct. Yeah, right. So essentially this is 0, 1, 2, 3, 4, 5, 6, 7, and 8, and our median would be at index 0, index 4, of course, and that's going to be 5, right? That's correct. Okay. Super. So how can we go about doing this in a more refined way or more elegant way is the question right now, correct? So we can do it using a technique called the boundary search, right? So how can we use the boundary search here? So we know that our rows are all sorted, right? All the rows are sorted. So what do we need in a boundary search? We want to know the last. So again, this search is going to be the number space. It's not going to be the index space. Remember that. So remember, if you look at the solution we took for, let's say, finding the kth smallest element, right? There also we looked at the boundary solution as in boundary search as a solution, as an option, but we looked at the index, we looked at the number space and not the index space when doing the boundary search solution, right? So, and we're going to employ a similar thing there here as well. Okay, so what do we do here? The first, so in the boundaries, so looking at this one, right, we need to know the highest number and the lowest number, right? So we need to find the highest number and the lowest number in this particular matrix. And then what can we do? We can go ahead and do a boundary search in that particular range, right? So I'll go across each of the rows, right, and try to find the min. Essentially, I go here, right, and I look for the min, right? The min here obviously is going to be the first element in the row, which is going to be 1, and the max is going to be 5, right? Okay, I do a similar thing for the second row. This is going to be 5 and 9, and here 3 and 9, right? And in each time during the iteration, I check if 1 is less than 5 or it's less than 3, right? If that is the case, I update the min. Otherwise, I retain the 1 here. Remember, this row at 1, right? It could also have been the first row, right? In that case, our minimum would have been present in the second row, right? 1 would have been in the Over here, it could have been present in the second row, right? Similarly, so this is going to be our min, and we also find the max right now. If we look at them, right, the last column of each row, we see that 9 is our maximum, right? Okay. All right. So also, remember, we need to know the number of items which need to be less than or equal to our median, right? So what would be that number? What would be the desired count? So in order for a number to be called a median, we need at least 4 items less than or equal to that number, right? So in this case, we have 4 items which are less than or equal to 5, right? So that's why it qualifies to be a median, right? So we need a desired count of numbers. I'm going to call that desired count of numbers which need to be less than or equal to a particular number to be qualified as a median, right? So what is this going to be? This is going to be the number of rows and number of columns, right, divided by 2, right? Okay. So now we have this one, and then we have the max. This is going to be the min and the max, right? We have both of them. So we can run a boundary search between this particular range right now, right? So we can go through this range and check the number of the count of numbers, right? Okay. So we can go ahead and then we get the max and the min, right? So we get the min and the max, right? So what do? We want to execute all our logic while in this particular range. So we can say while min is less than max, right? We can find out the mid, right? So we can check, we can find the mid here, right? And we want to know if the number of the count. So we want to find the count of smaller elements, smaller than or equal to mid, right? Okay, so let's assume that this is going to be x, right? Let's assume that this is x. So what is going to be our first, and we're going to do this for all the rows, of course, right? The count of, because we want to find out, let's assume that our array is something like this, right? Let me go back to that example that I was looking at. 135, 569, and 369, right? 135, 135, 569, and 369, right? Okay, so let's assume that our, excuse me. So if I look at the min and the max right now, min and the max is 1 and 9. Mid is going to be how much? It's going to be 1 plus 9 divided by 2, and that's going to be 5, right? That's going to be the mid. So now we want to find out the count of elements less than or equal to mid, right? So this is the mid, and what is the number of elements which is less than or equal to mid? So we have 1, right? We have so we have to go through each of the rows, right? And then we have to maintain a counter, right? So right now we have 2 in the first row, 1 in the second row, and 3 in the 1 in the third row, right? So eventually that turns out to be 4, right? And that is nothing but our desired count, right? So in certain cases, the desired count may not be matching. So let's say if the desired count is matching, then we can say the mid is actually our is going to be our median, right? In case, let's say if x is less than say the desired count, right? So let's say if x is less than the desired count, what do? We need to increase our min, right? Give me a moment here. My cursor is stuck, so I'm just trying to get it sorted out. Okay, so if the count is less than desired, which is going to be the x, right? If it is less than desired, what do? We want to update our min, and we want to search in the upper space, right? I'm going to say min is equal to mid plus 1, right? Similarly, if count is more than desired, right, we need to search in the lower space, right? So I'm going to say max is going to be equal to mid, right? So finally, so we'll run this until min is less than max, right? At some point in time, min is going to cross over, x, right? They're going to overlap, right? So I want to run this only until min is less than max, right? And once we come out of this, the last min is going to be equal to our median. Okay, so that's how we're going to go about doing this particular thing. Yeah, so let's go ahead and start coding this one out, and then some of these things will be clear, right? I'm going to go back to the IDE here one more time. Okay, so I'm going to close it. I'm going to say this is going to be find median, but a second solution. I'm going to say find underscore median. Yes. Okay. Okay, I think I need to make it 2 underscore 2. Okay, there we go. Okay. Let's get started. All right. So I'm going to get myself a function. Let me collapse the sidebar. So this is going to be const of find underscore median, right? It's going to get a matrix, right? And let's also get the number of rows and the column. Okay, we could have actually derived it, but let's actually take that in. Okay. All right. And so first thing is we want to define the minimum and the maximum because we want to do a boundary search, right? So I'm going to say let min is equal to some big number, and I'm going to set that to infinity. Okay. And let max equal to some low number, and I'm going to set that to negative infinity. Okay. All right. So what is the first thing that we need to do? We need to find the min and the max, right? So I'm going to go through each of the rows, right? Remember, when you go through each of the rows, the first element of the row is going to be a min element, and the last element of the row is going to be the max element for that particular row, right? So we need to keep track of the min and the max as we go through each of the rows, right? So I'm going to say for it's going to be a for loop. I'm going to say for let I is equal to 0, I less than R, I plus plus, right? So we want to run it for each of the rows, right? Okay. So I'm going to say if matrix at I0, which is going to be the first element of the row, right, is less than min, right? Okay, which is going to be the case because this is set to, the min is right now set to infinity, right? If that is the case, we will reset that. So I'm going to say min is equal to matrix at I0. Okay. Similarly, if matrix at I and the last column, how do we get the last column? By saying C minus 1, right? If this is greater than the max, right? We'll go ahead and reinitialize max. I'm going to say max is equal to matrix at I c minus 1. Okay. So at the end of this loop, we should have our min and the max, right? So we should have our min and the max. So what does it allow us to do now? It will allow us to do a binary search, correct? Okay. All right. So let's actually get the desired count, right? For a number to be called a median, what would be the number of elements which should be less than that, right? So let's say let desired count, desired underscore count is equal to R multiplied by C, which is row multiplied by column divided by 2. Okay. You can actually make this a integral function by saying math.floor. I think that's also something that we can do. Math.floor. And this is going to be this. Okay. All right. So now we can run our binary function within this min and max range, right? So I'm going to go here and then clear the screen, readjust the screen to be precise. So I'm going to say while min is less than max. Okay. I want to compute the mid to begin with, right? And say const, not const, it has to be a let mid. It's going to be math.floor, of course, min plus. This is another way of finding the mid. Essentially, they say this is going to avoid the overflow, right? Max minus min divided by 2. Okay. All right. And now what I would be interested in is finding the number of elements which are less than or equal to this mid, right? So I'm going to say let mid, not mid, it's going to be let count equal to 0. So I'm going to go over each of the rows now, right? So I'm going to say for let I is equal to 0, right? I less than R, I plus plus. Okay. I'm going to get the count, right? So I'm going to say find smaller elements, right? So smaller, and this is going to get the matrix and the row number, which is in this case it's going to be I, and of course the column as well, right? Which is going to be always constant and for us, right? And the mid. Right? So we want to know, given this particular row and the column and the total number of columns, that is, right? What are the total number of elements which are smaller than or equal to this mid number, right? So I'm going to essentially, this is going to return us a number, right? So I'm going to add it to the count. So I'm going to say count plus equals number. Okay. All right. So this is going to essentially loop through all the rows, find out the count of numbers which are less than or equal to the corresponding mid here, right? Which we've calculated. Okay. So first thing I want to do is if count is equal to desired, right? Desired count, we can say we got the answer, right? So I'm going to say return mid, right? This is going to be our median. However, if the count is less than desired, what do we have to do? We have to search in the upper space, right? So I'm going to say if count is less than desired, count. Okay. We say min now becomes mid plus 1. Okay. Otherwise, this is the only other condition. Else, max, we're going to search in the lower space, max is equal to mid. Okay. Right? And so this is all that there is to it. And finally, when min is no longer less than x, we will exit the loop and we will go ahead and return min. That's going to be our median. Okay. Oops. Okay. So now we need to go ahead and implement the function, which is the find smaller, right? So I'm going to go ahead and copy this. So this is going to be const find smaller, and this is going to be an arrow function. Okay. And okay. Okay. All right. So in this one, I'm going to say define a variable for the count. I'm going to say let count is equal to 0. Okay. And I'm going to run through only for this particular row, right? I'm going to go through the and all the columns, right? So I'm going to say for let I is equal to 0, right? And I will go through all the columns, right? And I less than C. I plus plus. Okay. So I'm going to say if the value is going to be the matrix at R in this particular row and particular column, right, is less than or equal to mid. Okay. What I want to do, I want to increment the count, right? So I'm going to say count. So finally, we'll go ahead and return the count here. Okay. That's all that there is to it right now. Okay. So we got the median function here. It's going to call the find smaller and then eventually give us the number of elements which are less than or equal to the corresponding mid. And every time it is, let's say the count is less than the desired, what do? We actually go ahead and then increase the min. If it is more than the max, we go ahead and essentially decrease the max, right? We change our bounds, right? That's all that there is to it. Okay, so let's go ahead and see if this actually solves the problem for us. Okay. So I'm going to go back here, remove a little bit of white space. Okay. And let's actually try with some inputs, right? So let's try this one, right? I'm going to say let input equal to it's just going to be a 2D array. So I'm going to say 11. Okay, maybe try with this one. 1, 3, 5, right? And 5, 6, 9, comma 3, 6, 9. Okay. All right. So I'm going to say console.log, and I'm going to call the function and say find underscore median, and this is going to be input. Oops, input, and 3, 3. Right. That's the number of rows in the columns. Yeah. So let's see if it actually gives us a right answer. Right. So we should be getting 5 as our answer, correct? Is that right? Okay. So I'm going to say node find median underscore 2. So let's see if we actually get an answer. We got an R is not defined. This was at 8. Line number 8. Okay, this is actually R. Okay, it's my mistake. Typo. Okay. Don't find median. Yeah, there we go. We get 5, right? Let's test it with another input. I'm going to go here and give it another input, right? So I'm going to say input is going to be equal to. So this was 11, 13, and 15, right? And 12, 16, and 19. Okay. And 13, 16, and 19. All right. So here it would be 15, right? 15 would be the median here, right? So we have 1, 2, and 3, and 4. Yeah, 15 would be the median. So I'm going to go ahead and then invoke this one more time, and we are getting 13. How come? So no, I don't think this is correct. Okay, I think 13 is at 4, right? So ideally, okay, let's actually get this one right. So we are saying this is 11, 12, 13, 11, 12, 13, 13, and 15, 16, 16, 19, 19, right? So how many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 0, 1, 2, and 3, and 4. Yeah, 15 should have been that. Interesting. Okay, I didn't save this. Okay, let me see. Okay, it's still saying it's 13 currently. Okay, let me check what's actually happening there. Okay, so something obviously is wrong here. We need to check what's happening there. Did we do something incorrect? I think the problem would be in the smaller, in my opinion. Smaller, find smaller. Okay. No, I think it is looking okay. Let's RC. Count is equal to 0. Matrix RI. And plus plus. Okay. All right. And then find the median. Hmm. Okay. All right. Come on. Count is equal to met. This is looking good right now. Actually, that's actually error. So let's actually write this one down. I'm going to say count is equal to start count. Console log. Let's look at whether we can actually go ahead and then debug this one. Min, mid, max, count, hard. Okay, let's see. We bring it here, and then we can also check here in case it's returning here. Console log min. All right, let's check this one more time. Okay, it's just coming out of here. And that is 13. Okay, in that case, I think probably it'll return max here, not the mid. We're returning mid here, right? We should be returning the max. Okay, I think that was my mistake. Interesting. I don't think that's. Okay, I think there is some typo here that I probably am missing, and it looks okay to me while min is less than max. Okay, and we're doing this. Fix IC mid. Okay. Sire. Okay, so I think there is something that is missing here, but I feel that the logic is looking okay right now. Just that there is some minor thing that is probably missing here. Okay. Nice. Let's check one more time. If matrix Ri is less than or equal to mid, then count plus plus. Yeah, it's looking good. Find median. Matrix I 0, matrix I C minus 1, while min is less than. Okay, the only thing. So if I remove this one, I don't think it should make any difference. I don't think it should make any difference. I think it does make a difference. Interesting. All right. Oh my goodness. So why is that? So if I do console log of desired count, okay. And if I do, let's say, let me actually recreate that. Some number is going to be equal to math dot floor. Okay. And this is going to be r multiplied by c, right, divided by 2. I'm not sure what the difference here is. We can check that. It's a desired count, and okay, desired count actually here gives 4.5, and this one gives 4. This gives a num of 4. Okay, so here's the thing, right? If you choose this one, mat.floor, you have to return the max here. Okay, you return the max here. If you choose the non, or you could also do a mat.seal and then choose mid here, right? That is also possible. Okay. Anyway, I chose to go without the integral here, so that is why it's causing this particular change in desired output, right? Okay. So any questions, folks? Let's come back to the timing complexity here, right? So time complexity here is going to be equal to, since we're using boundary search here, and we are doing boundary search for R rows, right? R rows and C columns, right? So this is going to be R log of C, right? And of course, we compare it with all the elements, so that's going to be of n in there, right? So this is going to be the overall complexity here, order of R log C and order of n, right? So that's how it looks like right now. Any questions, folks? Any thoughts? Are you there with me? Can you hear me all right? Okay. All right. So I think that was the last problem for the day and for the series, of course. So yeah, I just wanted to thank you for being present and being interactive and engaging. It was a pleasure talking to all of you. And I wish you the very best as you move forward. And you were also asking for the code link, right? Let me go ahead and then provide that to you. So I have essentially given the links here. It's essentially here. Okay, can you check this one out? Okay. So the code for all the sessions that we conducted, right, over the past week or so, all of this would be here. All right. Are you able to access that? Hopefully, yes. Yeah, you can look for my name, right? Prasad Katti. You should be able to find me out. It is Prasad Katti, I think. It's my name, Prasad Katti. Okay. Yeah. Again, it's nice talking to you, all of you, and thank you for being very polite and very cooperative, and appreciate that. I had a lot of fun engaging with you, sharing some of the things that I know, and I hope you liked the content that was actually presented, because yeah, it is going to be the last class, because we have finished all the other, in fact, we've finished all the series, all the sessions for this particular series, right? So it is going to be the last one. In fact, yesterday was supposed to be the last, but we had this spillover, so we had to do this additional class, right? So yeah, I just want to wish you all the best, and hope you do well wherever you go. All right. Is there any other question or clarification that you wanted to add? Okay. All right then. So can we close today's session today? If no one else has any other question to ask, yeah. Okay. All right then. Thank you, folks, and good evening. Hope you'll have a good rest of the evening, and wish you all the best, and do well. Yeah. Okay. All right. Bye bye.